Hey, how's it going, Nikki? Oh, my music is blasting right now. Yeah, my bad. Or yeah, so we're gonna be working more on these dynamic chains. I was like way too tired last night to figure it all out, but you got it today, hopefully. Chain temp. So we want to grab. Working on the art. That's interesting. So yeah, we are getting them to spawn right now because they're rigid bodies. They just fall everywhere. But we'll fix that pretty soon. Oh my goodness, this makes our game like hella. What sort of art are you working on? Alright, so we've got all of our chains put in. We're going to want to figure out how to put these pin joints in. We're going to duplicate them and then set... we're going to have to record our alt chain and our new chain. We'll do chain A and chain B. Or think about this. Just set chain A to true, and then whenever we iterate through each of them, we'll make sure that it switches back to chain B. I'm just thinking, do we always need to have an odd number of chains or an even number of chains? Or we're gonna have to figure out what to do there. Honestly, it might not matter too much. What we could do is just say, um, we'll just say chain one and chain two. These would just be paths. Need hotbar icons and stuff for the blocks. I see. Are you trying to make the entire game like super aesthetically pleasing? Hey, how's it going, Sparky? Alright, or chain temp is equal to chain, or conjoint temp is equal to conjoint to E duplicate, and chain position is equal to current position, and then this position is equal to vector 2, 0, -5. Let me see if we see our pin joints. And at the moment, what I think I'm going to do here, in our original pin joint, I'm just going to set, I set it to static for now, just so we can see what it looks like. Visible collision shape. I hope we see pin joints. No, we don't. Alright, that'll make things slightly difficult. Let me see. I took a caffeine pill this morning, which is like, it was 200 milligrams, and then right after I took it, I played like a couple of games of Valorant, and then I knocked out. I woke up like 2 hours later, and I took another caffeine pill, so hopefully I'm wide awake. Chain temp dot position is current position, and then yeah, our chain length is, I believe, 5. The thing is, actually, let's see here. Yeah, this is our origin here, and this is 1, 2, 3, 4, 5 pixels. Yeah, it should be right. Okay. So then, at this point, what we're gonna want to do, for every odd instance, we're gonna want to set chain 1. For sure, we're going to set chain 1 to our chain temp. And then we're going to want to connect it. So we're going to say pin joint temp dot, what's this? Node A dot set. dot set node B. Chain 1. Is 0 an odd number? Or even? Is 0 even number? Okay, so it is an even number, but is it also an odd number? Okay, it's even. All right. Go. So this checks for odd. Let's see here. So what we'll do is, if it's an even number, we'll set chain 1 to equal this. Otherwise, if it's else, if it's odd, we'll do chain 2 is equal to chain 10. And then what we'll do is, if we, let me think about this. Oh yeah, and then if it's odd, what's the best way to do this? Let me just go through it in my head. We have chain 1, we instance it, and then we set chain 1 to equal node A. And then if it's odd, we go for our next instance when it's 1, or our next iteration it's 1, which is odd. Chain 2 is equal to this. And then node B is chain 2. And then when we create chain 3, or chain 2, it's back to even. Chain 1 is it would switch to B. We'd have to set wait a second here. This would become, we'd create a new instance, and then chain 2, or our second chain, would be, we would have to set it to node A. So in this if statement, we want to check maybe if chain 1 already exists. Let's just do this. If I equals 0, we'll do this. If I equals 0, chain 1 equals chain 10. Join 10. maybe odd and even is not the best way to go about it. Yeah, let me try drawing this out. Maybe it'll make my life easier. Do some paint. Alright, so we have chain 1. So on our first, on 0, we get chain 1. And then, honestly, I think on our odd iteration, maybe that's when we'll add the pin joint. So then on 1, we'll have 1, and then the pin joint, and a second one. So I'll just do that. So at this point, we're going to want to set this to node A. I guess we can do this at this point. 0 will be, honestly, maybe we'll create these. We'll create these at 0, and then this is where the, I guess, actual logic comes in. This will be A, this will be B, and then by our second one, we're going to want our second pin joint and our third chain, and then this will turn into A, and then this will turn into B. Okay. Yeah, make one, man. There's this decent tutorial on making chains with pin joints, I believe, on Godot by I forgot his name. I think it's like Pixel something, or Pixel. I think his name is Pixely. He has a decent tutorial on it. Yeah, it's mostly for like ropes and stuff. So I'm gonna keep this here on the side. Actually, it's very distracting. Just close it. Oh yeah, I completely ignored the Euro 3D. Yeah. I feel like most things in Godot, that's what I really like about Godot, is that like you could easily convert a 2D game into a 3D game if you really wanted to. It's really just an extra axis. It's all the same thing. Okay, so I'm going to have to figure out how we iterate through this. I mean, it is a matter of just odds and evens, but at this point, all right, let's do this. If I equals 0, do this. Chain 1 is equal to chain temp, and then we're gonna completely ignore everything else. We're not gonna create our pin joints. We're gonna create our pin joints over here. Chain position is equal to current position. Yeah, we'll put these down here in. Let's do this. Because wait, let me make sure one more time. Yeah, for every 2, we only need 1 pin joint. So put it here. Our pin joint temp is equal to. Oh, but the other thing is that we still need to create the variable for our pin joint, because we are going to keep it for like 2 iterations. So we will keep it here, and we'll just say we'll actually just make another if statement checking if it's odd. This is going to be kind of sloppy. Oh, let's get rid of all of this. We'll actually set a variable for our pin joint here. Call it current pin joint. And pin joint position, we will also put here. And we also want to add to our current position oh yeah, we could keep it down there actually. Let's see here. So for odd, we're creating. Oh wait, yeah, that's right. Could probably get rid of this for now. Yeah, if it's even, we'll just put it down there. And we aren't setting node A just yet, so we'll do this when we're odd. So else we'll put set pin joint of this here. All right. And then at this point, we're also going to want to create a new instance, or wait, we already created one. So chain 2 equal chain 10. Okay, and then when it's even, okay, I think I figured it out. So at this point, we could set chain 2 to equal this, or chain B will equal chain current pin joint set B will be chain 2, and then from there, oh, and then once this is done, we'll just say chain 2 is equal to chain 1. or whoops, chain 1 is equal to chain 2. And then at this point, we're going back to our evens. What I think we could do is, since chain 2 are both the same thing, we could say if chain 2 is equal to chain 2, then maybe we'll make chain 2... Shit, man, this is kind of hard. Maybe I'm just too smooth brain for this. There has to be a better way to do this. You know what I could do is just iterate through. I mean, if we just have two loops instead of doing it all in one, I think it would make it simpler. I think I'm just stubborn. I think we could figure it out with just one. Chain 1 equals chain 10. Another thing we could do is try to create an array of all of these chains, and then that would help us like record it a little better. I think maybe that would be it'd be easier that way. Let's do that. So if we do it this way, what we could do is we'll do chain append, chain temp. Honestly, we could just put this in our... We can get rid of chain temp, but we'll leave it the way it is for now. Chain temp dot position is equal to current position. If odd, we'll create a new pin joint. And maybe we want to create a pin joint... Honestly, it doesn't matter too much. We're only going to be handling one pin joint at a time anyway. So if we're even... Let's see here. We're even. We're either doing nothing, but let's handle it for when we're odd. When we're odd, we're setting current pin joint set A of chain array at I -1. And then chain 2. We can honestly get rid of chain 2. And then this is going to be here, chain array at I. And then what? Okay, so if we're even, then what we could do is our new. Wait, this is odd. Honestly, wait. I think this might be it. I think this is all we have to do, if I'm not mistaken. Okay, so for even, we just create the chain. Actually, we don't even need this anymore. I don't think. Current pin joint set. This is 0. Get rid of this. And then if we're back to even, we just create a new instance. And then when we go back into it, we're grabbing -1, which is set to A. And then... yeah, I think this is it. Wow, that's a lot easier than I thought. Honestly, we can get rid of all of this too. Let me make sure we're up. I don't think we ever update it. Let's see here. 10, game position. Yeah, let's just get rid of these. We can get rid of chain 10. Position is equal to current position. Add child current pin joint. Start 1. I don't think we use this anymore. And honestly, we don't even need to. Okay, if odd. So we could put this here. Okay, I think that's all we have to do. We can get rid of all these other pin joints or all of these other objects. And then at the end of this loop, we're also just going to delete pin joint. Did we delete the wrong one? Oh, whoops, we did. Set node in base pin joint to do can now convert one argument from object to node path. There we go. So at the moment, nothing. I mean, we get the chains there, but they. Oh, it's because they're static bodies. All right. So I mean, one thing that's kind of strange about them is that they're not. Maybe they are connected. No, they're not connected. Let's see here. Oh, I closed it already. Let's run this again. Room 79. It might be that this room is saved as a different number here. Let's check. Yeah, it's saved as room 33. We need to fix that. But for now, look at our decor, chain links. We are getting the pin joints. Something about them is not working. Oh, I didn't know you could do that. You could like pause your game, pause your scene. Okay. So node A actually none of these pin joints have the they don't have doesn't seem like they have an assigned node. Pin joint is equal to pin joint 2. Let's do this. All right, so it is grabbing. Pin joint B is not being set for some reason. Let's look at that. Pin joint B set node. Um, oh, you know what it is? It's because we haven't added it as a child just yet. So let's actually put this over here. Um, Hopefully that should be it. We're still gonna want to add maybe like a root to this object because right now it's just gonna fall straight down. But if it's connected, it doesn't matter. So it is still connected. Come on, work with me here. So it seems like, if I'm not mistaken, seems like only half of them are connected to each other. So we are doing something slightly wrong, but I think we're close. What's strange is that we do have chain links here. I see something. Okay, so current pin joint A is 0, and then B is 1, and then once we start our new pin joint, it's going to 2 to 3 to 4. So we need to make sure that A is 1 here. So if we go back, close this. Where are we? So here it's saying so we're on our odd, and so we're on Is it -2? It wouldn't make sense though. But the only way it would work is if it was 2. So then this would be -1. Let's try it, see if it works. Yeah, it wouldn't make sense because, okay, right now on our first iteration, um, it's saying that this is chain 1, this is 2. That doesn't even make sense. Let's do it with like just 2 chains. Like right now I'm handling like every single chain. Let's just figure it out with smaller numbers. But what does look here, wait, this is A, this is B, this is A. This is B. You know, already. Okay, I think I figured it out. Hopefully, I figured it out. It should be -1. Doesn't make sense why it would be -2. So let's try to figure it out that way. Second here. Usually I have our thing print out. Let's see why it's not. There we go. Alright, so over here, when we're our first iteration, we get 0 and 1, which is right. And then on our second one, it's saying, I'm gonna print out I just in case too, because I need to make sure of these values. But yeah, this should turn into 1 here, or it's hard to show you guys. But yeah, this should be 1, and then the next one should be 2. So let's just print out what I is here. So oh, I see. Okay. So at this point, we're at 3. I am I guess I'm really bad at math. I don't know my odd numbers for my even numbers. I assumed for some reason it would be at 2. Um, so I wonder if this will still work. So at 3, we're grabbing. I guess we could check for if it's equal to 0 or if it's equal to 1. That's going to be the only case where we need to make sure it happens, and then going forward, it doesn't really matter. Or it'll follow the same formula, I guess. But at 3, so we have. Let's see here. On 3, we have 1, 2, 3, and 4. We'll have 4 chain links by the third iteration. So maybe what we'll want to do is, let's do this. We might want to check if it's even, and when it is even, because by the third, yeah, okay. So if I is equal to work I. We'll ignore 0 for now. We'll say let me think here. By our third iteration, we have 1 and 2 connected, and then we're adding this third one. And you know what? At that point, we're actually going to need another. 1, 2, 3. Oh, so my bad. Actually, we are going to need more than. For some reason, I thought we were going to have 2 pin joints or 2 chain links for every pin joint, but we're actually going to need a pin joint for every single one except, well, we're just going to have 1 less pin joint. So what we'll do is, see this. Position, and then maybe we'll want to create an array for these pin joints too. Might not be necessary, but since it's going to be, might get a little hectic here. So let's look at our output again. So if I doesn't equal 0, then we're grabbing the first one. So on 2, I'm going to say I minus 1. And then over here, when it's even, then we're also grabbing I minus 1, and we're saying B to that. So let's do this. Copy this over. Let's actually copy all of this over. Okay, so yeah, it works now. Obviously, it's like all crazy here. We're gonna fix that. But wait, let's make sure. Zero and 1, 1 and 2, 2 and 3, 3 and 4, 4 and 5, 5 and 6, 6 and 7, 7 and 8, 8 and 9, and then output overflow. Yeah, it does look like it's working. Now it's just a matter of figuring out like why it like bugs out like that. It might have to do with the positioning of our pin joints. Maybe I didn't set them up correctly. It's like right now it's turning into a blob. And what we can do here actually is when it's 0, instead of saying we'll still create a new pin joint here, but we won't add it to our thing. We'll just say pin joint duplicate. We'll say current. Oh, actually no. We'll say var temp. Current position. This is going to be our parent. And then this will be I, or 0, doesn't matter. Yeah. this might not work because it's technically not a static body. We might want to grab the static body here. Put it in. Actually, no, let's just try it. Although it probably won't work. Yeah, okay, yeah, it won't work. And that's because we start from the bottom to the top. So we're actually going to want to add this to the top. So maybe we'll ignore this for now. Another thing I think we might have messed up on is I don't know if the positioning matters for our pin joints, because like technically maybe we'll want to make we might want to switch these around. Yeah, we'll switch them around. I completely forgot we're going from bottom to top. And in my little diagram I made, I was doing the math from top to bottom. I don't think it'll make much of a difference, but it's worth testing out just in case. Yeah, and then that happens. Another thing I'm going to do is for our chain links, I'm going to put them on a different collision layer. On a different collision layer, we're going to put them. Let's see here. Just put them on 28 for now, so they can act independently. Oh no. Then they just fall through. Okay, wait. So, another issue is that it's because we're an odd number. Let's see, we're doing increments of 5, so we need to make sure that it's like at least 40 tiles away, or 40 pixels away. Grab a calculator. 40 divided by 8. It's 5, so 5 tiles away. One, 2, 3, 4, 5. And we will keep the same collision for now. Why are you guys doing this? Why are you acting so weird? It's like almost perfect. Oh, wait. It looks like we're on the right track. what I am going to do is I'm going to add a sprite to our pin joint. Okay. Go back into visible collision shapes. Let's run this one more time. I hope we could see the pin joints. Okay, we can. But something's going on here. The pin joints aren't moving. I'll be right back. I have to bathroom. Oh, right, because we queue freed it. Let's comment this out. Run it again. So the pin joint position doesn't really matter. Probably get rid of that. All right, so we could work under the assumption that Unless maybe it's because we didn't set a value for it. Let's just put it. Let's do this. Let's set B to our static body right here, which is where. Well. Okay, yeah, so their positioning doesn't matter. What we'll do next. I think the main issue now is just that we're colliding with the tile map here. Let's figure out the math for that. But another thing we could do is just see. We can make this our anchor here. Collision 2D. Let me see if we could just make this our... No, it has to be some sort of static body. What we could do is actually set our last chain to a static body. It wouldn't move at all. You know, I'm hoping this isn't a complete waste of time. Like we're messing around with this, but at the end of the day, honestly, I might not even continue working on this chain, or like I might not even add it to the game. We'll see. So let's do this. Oh, we are printing our tile distance. Let's look at that real quick. Tile distance is 16. Pixel distance is 40.02. Oh my god. Let me make sure that we round that, I guess. That is very strange. $40. I mean, honestly, that shouldn't matter. Actually, it should still be like our actual position is still right there. So what I'll do for now, just to test this out, we'll do this is 1, 2, 3, 4, 5. One, two. So what we're gonna do is, I think we can create another pin joint, one final pin joint. I'm wondering, does it really matter? Yeah, let's do that. If I is equal to the position doesn't matter, so all we have to do is set node A and set node B. We'll do B is going to be equal to I, and this is going to be our static body 2. And for now, just so we don't lag out, let's put our collision layer 28. Still falling through for some reason. You know, it should be. Oh, it's because it's not. Wait, no, our recast is colliding, so it doesn't matter. See this again. But yeah, actually, I'm not seeing our collision box there. Let's see what's going on. Let's put this. I equals tile distance minus 1. So we go up to 13, and phi equals tile distance minus 1. This doesn't print for some reason, or we're never getting this. At least I don't think so. tile distance is 13. You know what I think it is. Tile distance should be an int. Maybe that's why I'm not getting it. There we go. Still falls off from the face of our planet, though. We gotta figure that out too. Let's run it one more time. It's running on 12, which is right. Yeah, so at this point it shouldn't be falling, but for some reason it still is. Just it's like it's holding on, I believe. Let's put this 128 just in case. Oh, what the hell? Do we have another instance of our chains here? Because, see, tell distance is 22 here. We didn't move it. Yeah, it seems like we have two instances somewhere. Chain links. We only have one raycast. Nice. Yeah, but we're going all the way up to 20 for some reason. Um, room 70. Oh, I see. That's what's been confusing me here. Is like we're getting another instance of Chainlink somewhere getting printed out. I'm like, where the hell? I think I remember messing around with it. Yeah, it was right here. So, if I'm not mistaken, the positioning of these pin joints don't really matter. Find out pretty soon. But right now, it does seem like they matter. So let's try it. So another issue. Okay, I think I figured it out. I'm not sure if setting pin joint A or pin joint B makes a difference, but over here, um, they're switched. So pin joint A should actually be chain link one, and vice versa. So let's try that. I think that might be our main issue there. So over here, this is on evens. So we'll say here. So switch this with A and B. All right, moment of truth. This, if this doesn't work, I don't know. I don't know what will. Okay, and then it just hangs by a thread. Let me just make sure. A is 1, B is 0, then A is 1, B is 2. Okay, and then when we go to 3, honestly, we should be going back to 2 to 3, and then 3 to 4, and then 4 to 5. Okay, so we just didn't fix this. This is not correct just yet. So maybe it is A. We'll try this again. Over time. Zero, 1, 1, 2, 2, 3, 3, 4. Okay, these are all correct. Just make sure it's something. Same with 10 pin joint. Just make this a static body real quick. I want to see if they're like overlapping. Honestly, that shouldn't matter either. See something.
Do something interesting.
Okay, yeah. So pin joint positioning does seem to matter here. So let's go back here. I mean, it's most definite that our pin joint positions are wrong here. So let's go back. Let's see. Pin joint position is equal to current position plus vector 2, 0, -5. Actually, I don't think we need 0, -5 because it's already on the root. The root is like right there. So yeah, let's get rid of this. And it's rigid. Okay, so it does seem like it kind of works. It's hard to tell what it looks like down there, but um, what is our max distance here? Max distance is 13, which is 15 times 5, 65. But it's 60. Pixel distance is 40, so what we could try doing is setting, instead of doing all of this with the static body, what we could do is just, here, let's do this. We'll say, if we're on our final tile, chain array dot, let's see here. Dot set mode 1. And we'll remove our need for this this static body here. So let's just move it. There we go, it kind of works. It stopped moving. So I think the next step, let's see here. Just to make sure it collides well. Or we just need to make sure it doesn't bug out like that. just hide that for now. So it seems like at the moment they're colliding with each other. So let's go back here. Disable. Oh yeah, we never disabled collision. There we go. So we've disabled collision. So another thing to technically consider is that our origin is 1 pixel to the right, or like half a pixel to the right. So what I think we could try doing, yeah. What I think we could try doing is subtracting 0.5. All right, I think we almost got it. Now it's just wiggling around too much. And so for that, maybe we could increase, well, let's decrease gravity scale for now. Maybe that's pulling too much on it. And for now, let's double our damp here. we paused it. Moving. Okay, we've disabled collision. Our bias is 0.9 right now. Maybe we could reduce that. Maybe we could set it back to 0 for now. It's like almost there. Oh, shit, I think we got it. Oh, yeah. Okay, so now it's just a matter of fixing the positioning of it. I'm going to save that for next stream. I think, yeah, that's going to happen. We're going to get, it's going to freak out a bit. But I think that's a lot easier to fix. And I don't know about this. I'll have to fix the pin joints or something. I'll figure it out in another stream though, but we're almost there. But I don't know, it's not looking promising. We'll see. Alright guys, I'm gonna take a break.